Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. So this question says that Adrian Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other 2 in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it would be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared. And we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to 2 decimal places, so that will be 61.19. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the ft, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint, so our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. and then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9,000,000. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left-hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement. And we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be -4, 1. We're going to start this question by writing down what we know. So the toy car is travelling at 17 meters per second initially. So the initial velocity or initial speed is 17 meters per second. It accelerates for 4 meters per second squared. So acceleration is going to be 4 meters per second squared. And it's for 12 meters. Now, displacement just means distance as a vector, so we're we're going to use displacement, and we use the S to show displacement, just to be confusing. So displacement is always the confusing one. And we're asked to find the final velocity. Now the final velocity is shown with a V, so that's what we're looking for. So we're going to find out which of the formula we're going to use. Now notice we're not given the time, so all the formulas with t in them are not going to be useful. So we're not looking for or are given the t. And it's going to be the last formula, the v squared equals u squared plus 2as. Okay, let's fill in what we know. Well, we're looking for v squared. Well, we're looking for v, so we'll leave that. And so it's going to be 17 squared plus 2 times 4 times 12. And then when you work that out on a calculator, that comes to 385. And we're going to do some quick solving here. And we're going to square root both sides to get rid of that squared. So we get v equals the square root of 385, which is 19.621, etc. And it wants it to 2 decimal places, so we're going to write down 19.62 meters per second. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing. It's timesing the x by minus 6. So we're going to divide both sides by minus 6. So that gets rid of the minus 6 on the left-hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees, because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're Z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more. So she will have 516. And Rob has 69 fewer, so we're going to take 69 away from that, and that will equal 60. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that. So we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So the angle of elevation is when you are looking horizontally, like here. It's the angle that you have to look up to see something, so that castle. So this is the angle of elevation here, which I'm just going to call x. And we've got a right angle triangle here where we have two lengths and we're looking for an angle, so we're going to be using trigonometry. So we're just going to label this up. So we've got the opposite here, adjacent to here. We don't need the hypotenuse at all, so get rid of that. Let's just put our SOHCAHTOA in. So we've crossed out the hypotenuse, so it won't be sine or cos, it will be tan. So it would be tan x is equal to the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan of both sides. And so the inverse tan of 49 over 98 is 26.565, etc. And it says it wants the nearest whole number, so that will be 27 degrees. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we'll just go quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So the first thing we notice is the coefficients of the x's and the coefficients of the y's are different. But if we look at the y's, they are very similar. So we've got 3y and we've got 6y. So all we need to do is times everything in the top equation by 2, and then they'll be matching. So we're going to write out the first equation again. And what we're going to do is we're going to multiply everything in it by 2. And so I'm going to write that equation again, just so we can match up the equations nicely to be able to do our simultaneous equations. And I'm going to write the second equation just as it is, because it's already 6y. And get my bubbles in, because obviously we're working downwards. Now we're either going to be adding or subtracting these, and the way of telling is looking at the sign before the 6y's, the matching coefficient, and if they're the same, then we subtract. If they are different, then we add. Now these are both the same, they're both positives, so we are going to be subtracting. So we're going to subtract the top ones from the bottom ones. 10x take away 6x is going to be 4x. 6y take away 6y is nothing, which is good, because if we're left with any y's here, that means we've made a mistake. And 70 take away 54 is 16. And let's get our lines in, because we need to solve this last bit by dividing 4 both sides. And so we've got x equal to 4. Now that's only half the job, because we need to find out what y is. So what I'm going to do is just copy this first equation, but substitute in the value of x, which is 4. So 5 times 4 plus 3y equals 35. Get my lines in. And 5 times 4 is 20, so I'm going to take away 20 both sides to get rid of the 20. So we've got 3y equals 15. And then we're going to divide by 3 both sides. So we've got y equals 5. Now we can substitute in the values into the second equation. So 6 times 4 plus 6 times 5 does equal 54. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. First thing to notice with these simultaneous equations is that the coefficients of the x and the y are different. And whenever we're in that situation, unless there's a really obvious nice way of doing the x, I always focus on making sure that the y's are the same. So looking at the coefficients, the y on the first one is positive 3, and the y on the second one is negative 5. Now always ignore the signs, so ignore the plus and minus for this first part, because this first part, what we want to do is make the coefficient of the y the same number, but again ignoring any signs. So 3 and 5, the lowest common multiple of 3 and 5 is going to be 15. So what I'm going to do is just write out the 2x plus 3y equals 15.5. I'm just going to write that out, and we're going to just multiply everything by 5 because I want to make that coefficient of the y to be 15. And so that's going to be 10x plus 15y equals 77.5. And I'm going to do exactly the same for the second equation. So we've got 3x minus 5y equals minus 0.5. Get my lines in, and this time I'm going to times everything by 3 to make the coefficient of the y negative 15, but again we ignore the signs. So that's going to be 9x minus 15y, and that's going to equal minus 1.5. So when I put these two new equations next to each other, so we've got the 10x plus 15y equals 77.5, and we've got the 9x minus 15y equals minus 1.5. And if I draw my circles in going downwards, because simultaneous equations are all about working downwards, I've got to work out how to get rid of the y's, because that is my objective, is to get rid of those y's. So there's a little way of remembering this. If the signs are the same, we subtract. If the y's, if the coefficient of the y's are different, we add. So the s in same is the s in subtract, the d in different is the d in add. Well, here you can clearly see that they are different. The 15y is positive in the first one and it's negative in the second one. So we're going to add. And because we're adding on the y's, we add all of them. You've got to do the same sign all the way along. So working downwards, And let's get our line in just to make it clear what we're doing. We're just adding everything. 10x plus 9x is going to be 19x. And this is the key bit. 15y plus minus 15y. Well, that's just going to be minus. 15y minus 15y is nothing. And that's the whole point, is we want to get it equal to 0. And then 77.5 plus minus, so minus 1.5 is going to be 76. Get our solving lines in, and this is nice simple solve because we just go divide both sides by 19, get x on its own, and so x is going to be 76 divided by 19, which is 4. Now we can't just end there, we've got to work out what y is, because we know that x is 4. So what I'm going to do is pick one of the original equations, always go back to the originals, and I'm just going to substitute x in. So 2x, so it's going to be 2 times 4 plus 3y equals 15.5. So 2 times 4 is 8, so we're going to take away 8 both sides. And I'm not going to show all the working out here because we know what we're doing. So we've got 3y, take away 8 both sides, it's going to be 7.5. And then we're going to divide by 3 both sides. So 7.5 divided by 3 is 2.5. So our answer is y equals 2.5. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100. But what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah blah, and it says it wants it to 4 decimal places. So we're going to do 79.7854. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x? Equals 180, and let's get our solving lines in, and we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now we're looking for this angle here. That's angle ABC. Now there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. Here we've got a cubic graph, and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this, so we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one route and then up on the other route. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine a, what does a have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put a at -6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if a is -6, let's have a look at b. So what does b have to be? Well, if that's -7, if we put b as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if b is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the c, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is a, which is b, which is c? Actually, it doesn't matter. We could put A at -6 and A at 7 and B at -6 and C at 7. As long as one of these is -6, one and two of these are 7, you'll always get the right answer. So simultaneous equations we normally solve by working downwards and doing the circles and using the normal method on them, which is solving simultaneous equations by elimination. Sometimes though, when we've got a linear and a quadratic, which we have here, it's not possible to do that method. So what we've got to do is substitute one equation into the other. Now here, it's actually been nice to us in this question because they're both equal to y. So I can replace that second y with the 2x plus 11. I can just put that into that equation there, which is what we're going to do. So we've got 2x plus 11 equals x squared minus 5x plus 4. And we're just going to get everything equal to 0 so that we can solve it as a quadratic. So I'm just going to start by subtracting 11 both sides. So we've got 2x equals x squared minus 5x, what's that going to be? That's going to be -7. And then take away the 2x both sides. So we're going to have 0 equals x squared minus 7x minus 7. Now, we know this is not going to factorise nicely because it asks it for two decimal places. It's on the calculator paper. Chances are it's going to be quadratic formula we'll need, which we do. So we've got a equal to the coefficient of the x squared, which is just 1. B equal to the coefficient of the x, which is just -7. And then C equal to the number unknown at the end, which is -7 also. So we write out the quadratic formula. So x equals minus b, and always put them into brackets. So -7 plus minus the square root of b squared, so in brackets -7 squared, minus 4 times a, which is 1, times c, which is -7. Oh, and all of that over 2a, so 2 times 1. And when you do that with a plus in that bit there on the calculator, we get the answer of 7.887 blah blah blah. When you do it with a minus, you get the answer of minus 0.887. And don't rewrite the whole formula when you change from plus to minus. Just use the calculator function to go back to this sign and just delete it and change it to a minus. But when we solve, we've got to find out the x and the y values. So we look at this first equation here, which says y equals 2x plus 11. It means to find out what y is, all we need to do is times it by 2 and then add 11. So I'm just going to do that with the first solution we have, so 7.887, blah, blah, blah. I'm going to times it by 2 on my calculator, and then plus 11. And that gives me the answer of 26.774, blah, blah, blah. Then I'm going to do that with the second solution we found, so minus 0.887, blah, blah, blah. Go times it by 2, then add 11. And that gives me 9.225, blah, blah, blah. So to two decimal places, our answers are going to be 7.89 and 26.77, or minus 0.89 and 7.23. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top. Then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that'll be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. So we have the original y equals fx shown in the graph. And it says it has a minimum at 1 minus 1, so it's this one is the black line here, and we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.